Now that we've completed the setup, let me give you a quick summary of what you'll learn in this video. You'll start by getting familiar with the ideCAD interface, including how the ribbon, tabs, and quick access tools are organized. Then, we'll focus on the structure tree, your central hub for managing the entire project. We'll review how to define steel materials, select from standard codes, and create custom materials if needed. Next, you'll learn how to access section libraries and create custom steel sections, including cold-formed and built-up types. You'll also explore the analysis section, where static, modal, and response spectrum options are configured. Finally, you'll learn how to review and define automatic or user-defined load combinations so your model is fully prepared before moving into the design phase. Now, I'd like to give you a general introduction to the interface and its layout. If you have attended the reinforced concrete design trainings, you're already familiar with this interface. On the ribbon menu, starting from the top toolbar, you will find tabs for reinforced concrete, steel, and steel connections, followed by frequently used modeling tools for quick element placement. Separate tabs are available for analysis and design, reports, and drawings. We will cover each of these in detail in later sections, so I will skip the details for now. Let's focus on the Steel tab for now. Keep the top toolbar set to the Steel tab. Just below it, you'll see a row of icons. These are quick access tools designed to streamline the modeling process. I'll explain and use these commands when necessary during the modeling workflow. We'll be using all of them step by step. What I especially want to highlight now is the structure tree. You can pin it by clicking on the small pin icon. Once pinned, the panel remains fixed on your screen. Why is the structure tree important? Because it essentially summarizes your entire project. It starts with materials, continues with sections, analysis, design, reports, and drawings. It allows you to quickly access everything at a glance. Let's start under the Design tab in the Structure tree by looking at materials. You'll see one material for concrete and one for steel. Since we will be working on steel modeling, let's go over how to add a new material. Right-click on the Materials section and select Add New Material. Let's take a look at the window that pops up. First, you see the name of the material. You have three options for material type: concrete, steel, and other. I'll keep it on steel. Materials are classified based on their yield strength. For example, S235 is already defined, and S275 and S355 are also available because I selected European standards. If I choose S275, the software automatically loads the relevant technical properties, including ultimate tensile strength, which you can see is updated accordingly. Below, you can also see properties like elastic modulus, shear modulus, Poisson's ratio, unit weight, and thermal expansion coefficient. These fields are locked because these values follow the governing design codes, and modifying them could lead to inconsistencies. This distinction is important because design codes vary between regions. For instance, the elastic modulus values used in Eurocode differ from those used in American steel design codes. If you switch design codes, the software automatically recalculates these properties according to the selected code. This prevents accidental errors during modeling. However, you'll also see a Convert to Custom Material button. By clicking it, you can unlock the fields to define a custom material. For example, if you wanted to input properties for aluminum. Note that the software only performs design according to hot-rolled steel codes, so even if you enter aluminum properties, you must input correct values for yield strength, tensile strength, and elasticity. Aluminum-specific design checks are not performed by the software. Also, We recommend renaming any custom materials to avoid confusing them with standard materials and potentially causing modeling errors. I clicked OK, and now you can see that the material has been added to the library. Below, we have sections, divided into reinforced concrete and steel. Clicking steel reveals all section types available in the project, such as L, U, pipe, and box profiles. We'll access these when using steel modeling commands like steel columns, beams, purlins, and bracings, and you can choose between European and American sections. If you want to add custom built-up sections, the software provides convenient tools. For example, right-clicking on steel and selecting Load Section from Library allows you to access the standard European and American section libraries. Now, let's go over how to define custom steel sections. Right-click on Steel, select Create Custom Section, and you'll see two options: Single and Combined Sections. Under Single, you have options like Rectangular, Fabricated Castellated, Angle Types, Box and Pipe Profiles, and Cold-Formed Sections at the bottom. Let's focus on cold-formed sections. These are not included in the standard library. If you want to add a cold-formed C or Z section, you must do it via the structure tree. For instance, if you select cold-formed C, you'll notice the fields highlight in blue as you hover over them, indicating editable fields where you input dimensions based on your section tables. The software only performs design for cold-formed sections when they are used as purlins. Cold-formed sections are not supported for general element design or connection design within the software. Also, cold-formed C and Z purlin design is only available according to American design codes. Let's now proceed to combined sections. You'll see various types here. Let's select an L-shaped combined section. Below, the method options are available. And you can set a clearance distance to allow enough space between profiles. After adjusting the distance, I clicked OK, and the section was added. For another example, let's select an H-shaped built-up section, define the method. Choose Next Section, assign a name like HEB 400, HEB 450, and click OK. You can see it appears correctly in the structure tree. You can always use the structure tree to create and manage custom sections as needed. Moving on to the analysis section. Since we haven't modeled anything yet, you won't see any nodes or members. However, after modeling, each item's analysis details will appear here. Under the Analysis heading, you have Static Analysis, Modal Analysis, and Current Load Cases. As you progress through the model and define loads such as snow, wind, and seismic effects, you'll see them automatically appear in this section. In Modal Analysis, when you double-click, you can choose between Eigenvector and Ritz vector methods. Ritz vector is the default option, but you can change it anytime. The software targets 120 modes and aims for 95% mass participation. You can see and edit the degrees of freedom below. The software performs 3D dynamic analysis by default. Next, under Response Spectrum Analysis, you'll find the related function. You can define seismic loads according to your selected code, and parameters like damping ratio, direct combination method, SRSS or ABS, for X and EY, and gravity acceleration factor are available here. The gravity factor is set by default. Below, you have load combinations. Currently, only the combinations for reinforced concrete are predefined because we haven't modeled anything yet. The software generates load combinations automatically based on the selected design code. You can view all auto-generated combinations after performing the analysis. Below that, you can add user-defined combinations. Right-click to add new combinations, add new rows, choose load cases, edit factors. And specify linear or envelope types. Options are available to use them in reinforced concrete, soil stress checks, or steel design. Currently, reports and drawings sections are empty since we haven't modeled anything yet. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.